amazing. Now we're going to see about Mistral fine tuning. Mistral AI released its own code and few examples to fine tune. We don't need to use our computer to fine tune. We can use Mistral AI server to fine tune these models. And you can see now you can fine tune Mistral 7B and Mistral Small. You are able to fine tune on specific tone, specific format, specific tile, coding, domain specific augmentation, knowledge transfer, and for agents for function calling. So what is fine tuning? It's a process by which you teach the large language model on what to say and how to say it. We also have detailed instruction on how to fine tune, and finally create a user interface like this where you can use the fine tune to model. That's exactly what we're going to see today. Let's get started. Hi everyone, I'm really excited to show you about Mistral fine tuning. In this we are going to fine tune Mistral 7 billion parameter model. I'm going to take you through step by step how you can download and format the data, or you can use your custom data, then how you can upload the dataset to Mistral server, then how you can create a fine tuning job, check the status of the job, and finally use the fine tuned model in your own application. But before that, I regularly create videos in regards to artificial intelligence on my YouTube channel, so do subscribe and click the bell icon to stay tuned. Make sure you click the like button so this video can be helpful for many others like you. I am using Mouse Compute. Just type Mervin Praisen in the coupon code to get 50% off. First step, pip install Mistral AI, Pandas, PyArrow, Rich, and Gradio. Mistral AI is the main package. Gradio is for creating the user interface. And then click enter. Now it's installing all the required packages. Next, export your Mistral API key like this and then click enter. The command for exporting Mistral API key differs in regards to Windows, so keep a note of that. Next, export weights and biases API key like this and then click enter. So weights and biases are generally used for monitoring the training process, and that is optional. Now click enter. After this, let's create a file called data.py and then click enter. As you can see here, the first step is to download and format the data. So UltraChat 10K is a dataset which I'm going to use. It has prompt, messages. So messages is the conversation between user and assistant. As you can see here, the content, that is a role user, then again the content and role assistant. So it's like a conversation between two members. One is you and one is AI. So now we are going to teach the large language model how to respond when we ask certain questions. So in data.py file, first import pandas as PD, next importing rich, then we are loading the dataset by using pd.read and then providing the full path to this file. Next, df_train, that is the training data, then evaluation data. Training is the main list of data, and we are taking most of the data from here, and we are leaving some data for the evaluation. I will show that in a minute. Next, we are converting that to JSON L format using to JSON, and finally printing one data for our understanding. So that's it. Now I'm going to run this code. We've just loaded the data and then converted to JSON L format. In your terminal, Python data.py and then click enter. Now it got converted to JSON L format, and this is one of an example data. So here you can see content, role is the user, and content, role is assistant. So this is like a conversation between a user and an assistant. And similarly, you can customize this data with your custom data. So you can have your own questions here and then provide an answer here. Similarly, when you have multiple amount of data, you are able to train with your custom data. Here, this is a multi-turn conversation, which means you can see there's a question asked and then answer. So based on this conversation, there's a continuation and it keeps on going. So the large language model will understand how to keep up with the conversation with the context. Now, if you see, there are two files got loaded. One is train, another one is eval. So if I open the eval dataset, so this is the eval and it contains prompt, content, and the role. For your understanding, I just copy the first line and pasted that here. So you got the prompt, messages with the list, content, user, and assistant, then user, then assistant. So you can see multi-turn conversation. So that's what each line represents. So here you got 10 data, and UltraChat_train will have all other data. So that includes totally 1990 data rows. So we are going to teach the large language model with all this data. Now the first step is completed. So you've downloaded and formatted the data into JSON-L. Now the next step is to upload the dataset to Mistral AI server. Before that, I want to show you there are different types of dataset you can create for a specific purpose. For example, if you want to use specific tone, you can have your dataset accordingly. For example, if you ask how are you, then you can mention the type of tone you need when there is a response. Also, you can get that in specific format. So when the user asks a question like this, you can respond with this JSON format. Similarly, you can also provide that in different style. So here you're mentioning what type of style you need. So that's like the style guide. Next, if it's for coding task, then you need to format the data differently. So as a user, if this question is asked, and this is how the large language model need to respond. This is for text to SQL model. So you ask question in natural language and you get a response in SQL format. Similarly, you got domain specific augmentation, knowledge transfer, teaching the large language model with specific knowledge, such as the medical dataset. By providing all information about the symptoms, it is able to respond the exact sickness. You can fine tune like that. And also you can fine tune for function calling purpose. So it's all about collecting the proper data. Now we're going to upload the dataset to the server. I'm creating a file called app.py and let's open it. So inside the file, first import OS, then JSON, time, print, from Mistral AI, import Mistral client, then training parameters, chat message, weights and biases integration. Now we are getting the API key from the environment variable. Then we are defining the client. Here we are defining a function just to print the response in certain format. This is optional. This is just general settings. Now the first step to upload the dataset to the server. So here we are opening the training dataset, that is UltraChat chunk train. Next we are going to provide the eval dataset and then providing the path to the file. Now we are going to print the data for our reference, printing the training data and eval data, not everything but the structure. Now we have completed the step of uploading the dataset. So step number 2, creating fine-tuning job. So here we are using a function called client.jobs.create. There you are providing the model name. You can change this model based on your requirement. Here the training files, validation files, hyperparameters. You can change this based on your requirements. And finally, we are integrating that with weights and biases so that we can see a visual representation of the training. Now next, printing for our reference. That's it. So literally this bit of code and we have created a fine-tuning job. Next step, check the status of the job and then print for our reference. So coming here, step number 3, check the status of the job. Checking job status using client jobs retrieve function and using the job ID to check the status. Next, we are checking every single time. We are keep on checking when the job status is queued and running. Once after the status got changed from running and queued, then we are moving to the next step. Here we are checking every 10 seconds. Next, client.jobs.list and printing the jobs. That's it. Also, we are going to print the retrieved jobs. This will be used when we want to use the model. We'll get the model name. That's it. Just by calling this jobs.retrieve function, we are able to check the status of the job. Now step 3 completed. And the final step is to use the fine-tuned model. Use the fine-tuned model, chat_response equals client.chat and providing the model name. That is a trained model. Here we are asking a question, what is the best French cheese? And finally, we are printing the response. That's it. So just by calling client.chat, we are able to ask a question to the model. So as a quick overview, we uploaded the dataset, which we initially formatted. Then we created the fine-tuning job. Then we checked the status of the job. And finally, we are using the fine-tuned model. Now I'm going to run this code. In your terminal, Python app.py and then click enter. And you can see first the data got uploaded. This is the training data and here is the evaluation or the test data. Then a job got created with training steps, learning rates, and we are mentioning the training files and validation files. Here we are integrating that with weights and biases. And now we are checking the status of the job. So first we can see the job got queued and then after 10 seconds we are checking again. Here it says running and the second status is queued. That's for the second file. And I can see it's still continuing. You can see the training loss here. Finally, the job is success, waiting 10 seconds. and then we are printing the final. Here you got the name of the fine-tuned model and job status success. Next, we are going to use the fine-tuned model, that is this name, and then asking a question. What is the best French cheese? And here is the response. The best French cheese depends on personal preference, but some of the most famous and popular French cheese include, and it's giving me the list. You can even mention the model name here and keep this code separately in a file, and then you can test this model as well. So I've kept this code in a separate file, and I can even run python use model.py to get the response, as you can see here. In this way, you are able to integrate that with your own application. So this is the weights and biases dashboard, which we integrated, and you can see the training loss going down, which is good. And you can see the training other parameters and stats. In this way, you are able to monitor the training steps or training process in real time. Now finally, we are going to implement user interface using Gradio. I modified the code slightly, imported Gradio as gr, added all those commands inside get chat response, and finally you're using gr.interface and mentioning that function. Here the input is text, output is text. iface.launch will launch the user interface. Just simple bit of code with this 2 bits. Now I'm going to run this code. In your terminal, python ui.py and then click enter. Now I can open that in the browser, clicking that, and here is the user interface. What is the best French cheese? And here is the response. The best French cheese can be subjective, and it's giving me a list which are some of the most popular, highly regarded French cheese. Now you are able to fine-tune Mistral even if you don't have good spec on your computer. I'm really excited about this. I'm going to create more videos similar to this, so stay tuned. I hope you like this video. Do like, share and subscribe, and thanks for watching.